Let's now start with the EBS. So in this session, we discuss the EBS volumes and snapshots. So what is EBS, by the way? Let's get started with the basic concepts first, and then we will just start with the detailed overview. So EBS stands for Elastic Block Store. Okay, it consists of two different categories. There are two different types of EBS components. One is the volumes, and other one is the snapshots. Okay, so these are the other two different categories or the components that come under the Elastic Block Store. Fine. Now, starting from the volume, or I would say EBS volume. Now, what is this? Now, this is a block level storage device. A block level storage device, right? And you attach it. You attach block level storage devices. So volumes are block level storage devices that you attach them to the EC2/DB or database instances. Okay, you attach these EBS volumes to the EC2 or the database instances. I would say that they act as the virtual disk or virtual hard disk. Because you need to assign some storage to the instance, because when your instance boots up, it needs some hard disk, some space where the image files are being kept. You need to store some data upon that, program files, everything. It needs some kind of storage disk to boot from, to start from. So the thing is that at the initial stage, whenever you launch your instance, you assign a root volume. So a root volume is the volume that consists of the entire information to boot your instance from scratch. So it consists of the information to boot your instance. Okay, so whenever instance gets launched, it needs to reboot. The root volume consists of the entire information which is needed in those different situations. Fine. Now the thing is that the EBS volume, how this works for you, and the thing is that it guarantees the durability of your data and security. We'll come to this security part afterwards, because we'll discuss about the key management service or KMS. But let's now discuss that how exactly the EBS volumes are durable, or they guarantee you a higher amount of durability. So we have to understand that important part. See, what happens is, let's imagine this is my EC2 instance. So guys, I'll just go straight away for up to 9 p.m. and take the questions afterwards. Once I'm through with the concepts, then I'll just take the questions. Okay. So after 1.5 hours, I'll start taking your questions. So this is my EC2 instance, right? And this is my EBS volume. Okay. Now the thing is, you attach the EBS volumes to the instances. You attach them, plus you mount them. So they're being mounted. For example, let's suppose this is a Windows instance. It's a C drive or like a D drive. So for example, if you as an administrator, you log into this instance, this EBS volume would appear to you as one of the hard disk. It will be mounted as the like a file system, like you use NTFS. Okay, so it will appear to you that this volume is a part of the same server where this instance is running. But that's not the truth. The truth is opposite. This instance is maybe running on HP, IBM, or Dell physical server. On the other hand, this EBS volume can be running on, can be a part of a NAS, SAN, or a disk attached storage. So what I want to stress upon is that even though these two different components they appear to you as one, but behind the scenes they are running on separate hardware, on separate pieces of hardware. They are kept separate. Now this increases the amount of durability. How? See, first of all, you understand this thing. Upon this volume, if it's a root volume, for example, it's a root volume. It consists of the images or the image, plus it will also consist of the data. So basically, your EBS volume consists of the entire data. The data is being stored upon that. Now, since these are two different components that are running on separate hardware, what do you mean by that? If this instance terminates or the underlying hardware crashes, this is not affected. The volume on the other side is not affected. So the life cycle of the volume stays independent from the life cycle of the instance. Now the thing is that you can take this volume and attach it to any other instance. However, you have to just take care of one thing, that the entire thing should be in the same AZ. The entire thing should be in the same AZ. So this is a restriction that you have to look into, that the EBS volume is confined in a single AZ. The EBS volume is confined in a single availability zone. It's restricted in the single data center. This thing you have to keep in mind. So the EBS volume cannot bypass the boundaries of a data center. Now coming back to the durability. So the thing is that if the instance crashes or the underlying hardware crashes, that's fine. You can take the volume and attach it to any other instance in the same zone, and you can just recover your entire data. So this increases the amount of durability. Also, to add on, the data that you put in this EBS volume is being multiplied for redundancy and being saved across multiple servers in the same zone. So to keep the data more redundant, they ensure that the data that you put in the EBS volume is being multiplied and saved across multiple storage servers in the same zone. Because who knows, might be this EBS volume crash has crashed for some reason. Anything can go down, right? Anything can go down, even your EBS volume. So in that case, they ensure that, okay, if this EBS volume crashes, then your data can be recovered behind the scenes. So in the backend, they ensure that even if the EBS volume gets crashed or unavailable, they make the data of that volume redundant in nature behind the scenes. So they guarantee you the amount of durability that you need to ensure that your data is secure and it's always available. So that's the main purpose of using the EBS volume, to enhance the durability of your data and your image files, anything that you put on the EBS volume. Okay, so what do you conclude right now? The conclusion is that the life cycle of the EBS volume stays independent from the life cycle of the instance. Okay, so the EBS volume is not dependent on the life cycle of the instance. The instance stops, terminates, crashes. It will not affect the performance and the life of the EBS volume. Fine. Okay. Now, the thing is that so far we have been using Linux instances to perform all the lab sessions. Let's do one thing. Let's deploy a Windows instance right now. And we're going to be using that Windows instance to understand exactly that how the things work behind the scenes. So I click on Launch Instance. Okay. And this time I'll pick Microsoft Windows Server 2019 base. I click Select. Then I will just go with the t2.micro as my instance type. Click on Next Configure Instance Details. On the third step, I will not change anything else. I will just accept all the default values. Click on Next Add Storage. Now, this is where this adds on the root volume. This is a device name. So every volume would have a device name. Now, snapshot. See, these volumes are being extracted from the snapshots being maintained by AWS behind the scenes. This is the 30 gig of root volume. This is gigabyte. So this thing you have to understand. The unit we use is called the gigabyte. It's not gigabyte. So because there's a confusion over here. So over here, the unit we use to determine the storage capability of any volume is gigabyte. So it is 1 GB, which is the gigabyte. So 1 gigabyte is equal to 1.07 GB, which is the gigabyte. Okay, so 1 gigabyte is equal to 1.07 gigabyte. Fine. So by default, it adds on 30 gigabyte of the root volume to this Windows instance. Now the maximum size you can go up to is 16 terabyte. Okay, so the maximum size you go up to is, so what's the maximum size of each volume? It is equal to 16 terabyte. Fine. This is a maximum size of the volume. Now these are different volume types. We'll discuss them afterwards in detail. And IOPS and the throughput are the attributes, or these are the metrics through which you analyze the performance of the volumes. So IOPS and throughput. IOPS stand for input output operations per second. Throughput is for the long sequential IO operations. We'll discuss them afterwards. So these are volume types, and depending upon the type of volume that you have chosen, you choose the IOPS and throughput, or you get the level of performance that you need. We're going to discuss the volume types and IOPS and throughput afterwards. I would like to draw your attention to this simple option, which is very, very important. That is delete on termination. If I uncheck this option, this means that I make the volume independent from the life cycle of the instance. So I make the volume independent from the life cycle of the instance. So if I uncheck this option, what happens is that if this instance that I'm just going to launch, if I terminate this instance, then this root volume will not be deleted. And in the future, from this root volume, I can just carve out a snapshot. From that snapshot, I can launch a duplicate instance. So I can preserve the instance, its properties, its storage, its applications, its services, and softwares, everything. The main thing is that if you uncheck this option, delete on termination, then this instance that I'm in the process of launching, if I terminate this instance in the future, this instance will not be deleted. Okay. Now you can also encrypt it. Encryption we'll discuss afterwards, not right now, because my main purpose is that I just show you that how exactly that you just go ahead and start accessing and managing the volumes. Fine. So I will not encrypt this volume. We will discuss the encryption in detail afterwards. I can add more volumes. There's no limit how many volumes I can add on, but for simplicity, I would just go ahead and just add on only 130 GB of the root volume with this instance. That's it. And I will just uncheck this option, delete and termination. I click on next add tags. In the tags, I can just type in name, and in the value, just type in Windows Server 2019. That's it. If I just keep these two different check marked, this means that this key and value will be assigned to both the instance and the volumes of that instance. Now, I click on configure security group at the bottom left hand corner. I'm sorry, right hand corner. And I just pick any of the pre-existing groups right now. The main purpose is that I just pick any one of these. Okay, so I'll pick the Windows one because we would like to allocate or ensure that we can allow the RDP traffic. So okay, I think we have this thing. I change the source afterwards. So let's pick this security group. I click on review launch. I have to ensure that I have the copy of that key. Let me see that on my desktop because it's very important that I should have the copy of that key. Just give me a few seconds over here. I need to ensure that I have the copy of this key so that I can initiate the RDP access to this instance that we are in the process of launching, or else I will just go ahead and launch a new one. So I think let me just search for it once again. Okay, so let me just create a new one because I assume I don't have the copy of any key pair as of now. So I just create a new key pair. Let's name it as ELB demo. That's it. That's the name of the key pair that I'll be using to initiate the RDP access to the instance that I've just launched, or I'll be launching, I would say that. So I click on download key pair, and this downloads the private key. I can just cancel this out and click on launch instances. So as you can see that I've just launched an instance in front of you. It will take some time for this instance to boot up. After that, we will just go ahead and initiate the RDP access and manage its volumes or volume that's being allocated, or that's a part of the instance right now. Now, in the meantime, this instance is in the process of getting launched. I just go to my security group of this instance, go to inbound, click edit, and ensure that the RDP is chosen from my IP. Okay, click save. And in the meantime, I just search for this instance, and let's do one thing. Let's create a connection because I'm using Mac OS. So in that case, I have to depend upon this third-party software to initiate the RDP access to this Windows server. So I initiate a new connection, and I just copy and paste the public DNS name, and I just paste it in the PC name. And in the user account, I add the user account. The username is always the same. That is the administrator. And in the meantime, I just ensure that I can just go ahead and decrypt its password. So it's not available yet. So we have to wait for a few seconds before we can just go ahead and just decrypt the password. So I think so we should get. Let's wait for a few seconds before we can get the option to decrypt a password right now. Let's wait. Okay, let's try one more time. Okay, so now we can just go ahead and just go to our downloads and just decrypt it. Okay, and let's copy this right now, and we're gonna paste it. Click add. We just add the connection, and we just double click to initiate the RDP connection to this instance. Let's do that real quick. So right now it is getting initiated, and once it gets initiated, I'll show you exactly that how you manage the volumes from the instance perspective or the server perspective once you log into the servers. So as of now, I've just logged in to this Windows Server 2019. Fine, I've just logged in as of now. The next thing I'll do is that I just go to the start menu and search for this PC. Okay, so I just want to ensure that I can just look into the hard disk or the virtual disk that's being allocated to this Windows instance. So I click on this PC right now, and as you can see that it's local disk, and this is the 30 GB or 30 gigabyte of the root volume that's being allocated as a C drive. This is being allocated as a C drive. This is allocated as a C drive. Fine. Now, if I want to manage the disk, there's a program on the Windows servers or the Windows platform. You just go to the start menu and just type 3 keywords, RUN. That stand for run. You press enter or just double click on this app, run. In the run, just type in disk mgmt.msc. There's a shortcut. There's a shortcut that you use to go to the program from where you can just manage the disk. I click on OK, and this opens the disk management program on my Windows Server 2019. Fine. So this is the 30 GB of the root volume that's being mounted as a C drive, upon this Windows Server 2019. Fine. Now on the fly, if I want, I can just add on more volumes. The two options out. Either you just go to the once you are in the process of launching an instance, so you add on more volumes from there, or after you launch the instance, you can very well do that afterwards. So I go back right now and show you that process. So the thing is that I want to add on some additional volumes to this Windows Server 2019. So what's the process? I just go back right now, and the next thing I will do is that I just check that in which availability zone this instance is running. So this is the AP South 1B. Now why did I just look for that? The reason being because the main purpose is that the volume should be in the same zone, should be in the same availability zone where the instance is launching or it is being running, in order to allocate that volume to that instance. So the volume and the instance should be the part of the same availability zone. Okay, so I go to volumes on the left hand side, click on create volume. Now I'll not go with any volume type as of now. We'll discuss the volume types in detail afterwards, not right now. The size of the volume let's go with would be 10 gigabyte, a 10 gig. Availability zone AP South 1B, because the instance to which this volume would be attached is running in the same zone. I add a key value or a tag to it. So this is the name I will assign to it would be, for example, additional volume. Okay. And this is of 10 KB. Okay. And that's it. I click on create volume, and this creates my volume right now. I click close, hit refresh once again, because I think, yeah, here we go. So this is the additional volume of 10 gig that's being created. And if I show you the state, it is available. So what's the state right now? The state is available. If it's in use, this means that that volume which shows the status as in use is presently attached to the instance. But available means that it's not being attached to any instance right now. What I will do is that I will choose this volume, go to actions, and click on attach volume. So I choose instance. You can see that it gives me the option to choose instance in the same availability zone. So I choose this Windows Server 2019. It automatically picks the device name for the attachment. You don't have to change it. Click attach, and this attaches this 10 GB or 10 GB of the additional volume to this Windows Server 2019 that I've just launched. Now, if let's go back right now, and you can see that, okay, let's do one thing. Let's go to this PC. Okay, let's go to this PC where I can see all my disk. I hit refresh. You will see that it's not showing up over there. I hit refresh once again. It's not there. So what's the case? The case is that whenever you add on or you attach any additional volume to any instance, you have to follow a process to mount it. It has to be mounted. It has to be mounted. So the question really is that how you dismount it? The answer is simple. You have to follow these certain steps. I show the steps right now on this Windows instance. You see the steps and understand those steps. So I take the cursor at the left-hand corner of this program. Now, as of now, this disk 1 is unknown. There's a 10 GB of offline storage. This is offline. I right-click on this one and put it online. Done. So I change the status from offline to online. That's what I did. Then the next thing that it shows as not initialized. It is not initialized. I just right click on this one and click on initialize disk. Click on OK. Done. It is online, but it is unallocated. So you have to put you have to change the status of that additional volume from offline to online, and then you have to allocate it as one of the virtual disk or the local disk like D drive, E drive, F drive to this instance. So I just take the cursor on this space, just give a right click and just click on new simple volume. I just did that. It opens up, welcome to the new simple volume wizard. I hit next. I can choose a letter I can just assign a letter A, B, C, D, E, F, whatever I just go for to this volume. So I choose D drive, click next. Now it will format this volume using the file system NTFS. You can choose any other file system, but I'll just go with the NTFS. It will perform a quick format. I just go ahead and hit next, hit finish. As you can see that I've just mounted this additional volume as a D drive to this Windows Server 2019. I just performed this operation in front of you. Now, if I just go back to this PC, you can see that this is showing up. This is how you can add on the additional volumes to the instances, and you have to follow a process to mount them. The mounting process has to be initiated. Fine. So that's how you go about doing that. That's the process that you follow. So you can add on E drive, F drive. You can just add on some more disk. But sometimes there may come a situation where you may have to increase the size of the existing volumes. I can increase the size of C drive, D drive. It's up to me. But generally, it is not recommended that once you launch the instance, then you try not to change the properties of the C drive, because it's a root disk. If something goes bad with this disk, your entire instance can crash. But of course, you can change the properties. To be on safer side, it is always recommended that if you have changed the properties, that the size, the type of the volume, it's better that you apply those things on the extra volumes. So in my case, what I'll do is that I'll go with the D drive. Right now, the size of the D drive is 10 GB. That's the size of it. I will change the size of this D drive from 10 to 15 GB. So I will just add on 5 GB more. So what I will do is I just go back. Okay. And I choose my additional volume of 10 gig. Go to actions. And can you see that the option on the top which says modify volume? I just go over there. Once I just go to modify volume, then in that case, this is my volume ID. I'm sorry, this is the volume type. I will not change it. So the thing is that you can change the volume type. Now we'll discuss the types of the volumes afterwards. Okay, let me just go once again. I click on modify volume. I can change the type of it. We're going to discuss the types afterwards. But most importantly, you can change the size of it from, for example, 10 to 15. But you can't downsize. For example, if I just make it as from 10 to 9, you will see the message. The size of a volume can only be increased, not decreased. So this is a restriction that you have to look into. You can bump up, or you can just increase the size of the volume, but you cannot decrease it. This thing you have to understand. So right now, I just make it as 15, from 10 to 15. I will just add on 5 GB more storage. Click modify. Click yes. You can just get the notification. Modify volume request succeeded. Hit close. Hit refresh. You can see the size has changed. Can you see that? This one. And I can just modify the tag over here. And I go back, but there's nothing changed over there. Nothing has changed. So the thing is that whenever you just modify the volume, you have to just perform some actions on the server. So I go back to the disk management program, hit refresh. Let me just do that. Or let me just open it once again. I think it's not. Okay, I didn't attach. Okay, it's been attached, but why does saying I think it's in yellow symbol. It is still not available. Let me just go back once again over there. So it says, let me see that. We'll just refresh, because it may take some time for this to become available. Let me just go to the run menu. Let's type in disk management, diskmgmt.msc. Okay, here we go. So I reopened this program, and this is the 5 GB of unallocated storage, which I need to merge with the D drive. I need to merge with the D drive. So how do I merge it? I go to the D drive. I go to D drive, hit a right click and click on extend volume. Then it opens the welcome to the extend volume wizard. Hit next, hit next, hit finish. And I just merged the 5 GB of that storage with the D drive. And if I just go to this PC program, hit refresh over here, you can see the updated size of it. Okay, that's how you go about doing it. That's how you modify the volumes. Fine. So this is the thing that we were supposed to discuss. We discuss the volume types afterwards, but before we discuss the volume types, the next thing that we are supposed to discuss is this one. That is, we will now discuss the concept of the encryption. Okay, so over here, the encryption we'll discuss is the encryption of the volume. So let's discuss the encryption, and over here I'll discuss with you the key management service or the KMS. So let's discuss the next topic. That's the encryption. Let's just do that once again. So that's the encryption. See, why you want to encrypt something? See, encrypt means that it's like you're just putting a kind of a filter, or you encrypt in such a way that only the one who has that key can decrypt it. So what you do is that, for example, this is my volume, the EBS volume, and this is being attached and mounted to the instance. So you encrypt this portion, because at the end everything is being stored. Your confidential data is being stored on this volume. You encrypt it. Now whenever you encrypt any volume, the thing that happens is that the encryption occurs at 3 levels. The first level is that the data at rest on the volume. The data that's being stored, any data that's being stored on that volume becomes encrypted. The data at rest. The data that's staying at rest on the volume becomes encrypted. Each bit of information becomes encrypted. Okay? If you take the backup, we'll discuss the snapshots in detail afterwards. If you take the backup of this volume in the form of snapshot, so the snapshot is also encrypted. Also, the I/O operations, input-output operations between the volume and the instance also becomes encrypted. Fine. So whenever you encrypt any volume, the data at rest on the volume that's being stored on the volume, the backup of that volume, the snapshot, and the I/O operations, input-output operations, that's the data that flows between these two different entities becomes encrypted. It becomes encrypted. Fine. So this is how it goes. Now the thing is that how you perform the encryption. This is a very, very important thing. See, to encrypt the EBS volumes, we make use of a service that's called the KMS. It stands for Key Management Service. So how this works for you? So the KMS or the key management service will help you to just create, or I would say not create, but help you to maintain two types of keys. The two keys are, first one is the default CMK. CMK stands for Customer Master Key. What is CMK? Customer Master Key. This is a default CMK. It is also termed as AWS Managed Keys. Same thing. Fine. AWS Managed Keys. The same thing. Default Customer Master Key or AWS Managed Keys, it's the same thing. The second thing is the custom CMK. Slash, it's a customer managed keys. Okay, so what is that? That's the customer managed keys. So what's the difference? I'm just gonna state you the difference right now. It's a customer. Let's write once again. It's a customer managed keys. So the thing is that I think if you see the name, you already have got the basic difference. The default customer master key or the AWS managed keys are the one that's there by default, that are being managed by AWS. The custom CMK or the customer managed keys are the one that are being managed by the customer. So I think you already got the basic difference. You already got the basic difference between these two. The other difference is that the default customer master key or the AWS managed keys, they don't give you any amount of flexibility. They will not give you any type of flexibility that you would like to have. But the customer managed keys will give you a lot of flexibility. You can just change its properties. You can share it. I'll show you. So the customer managed keys can be customized based upon your need and the taste. So you can just customize it. You can share it. You can manage it on your own. Fine. So this thing is very important for you to understand. The service that you use to encrypt your volumes is called the KMS. That stands for Key Management Service. It consists of two keys. One is being managed by AWS, and the other is being managed by the customer himself or herself. So the customer master keys or the customer managed keys give you the flexibility that you would like to have. This gives you a lot of flexibility. Fine. So this is about the KMS. All right. Now the thing is that this thing you have to understand. This service is not free. This is not free. So KMS is not free in any of the accounts, especially in the free tier account. This is not free. It's not free. Even if you use a default CMK or the custom CMK, still will be charged. So I'll show you the process right now. I go to the services. Now to access this service, you have to go to IAM. Okay, that stands for Identity and Access Management. Now once I go to the IAM right now, the next thing I just go to is the encryption keys on the left side. And here you can see it has two main categories: managed keys and customer managed keys. Key store is a new option, still not, it's used with the cloud HSM. But you can see over here, customer managed keys, AWS managed keys and the customer managed keys. Okay. So if I just go to the AWS managed keys, now one thing that's very important, if you want to encrypt any data, or I would say right now we're talking about the we are talking about the volumes. You want to encrypt any volume, you have to ensure that the volume and the key is in the same region. This thing you have to keep in mind. The volume and the key is in the same region. So the volume and the key should be in the same region. So as of now, if let's go to AWS managed keys in the region of Mumbai, you will see that these are the AWS managed keys or the default customer master keys. And this is the one, AWS/EBS, this one, that I'll be using to encrypt the volume. This is a default key or the AWS managed key that I'll be using to encrypt my EBS volumes. So it is AWS/EBS. If I just click on that right now, you will see that it will not give me any type of option to change it, to configure it. It is plain and simple. Now the question really is that, okay, then why you have to use it? If it doesn't give you any type of flexibility, then why you have to go with the default keys or the default master key? Because the default master key is the one that when there's no other keys defined. We say this thing quite often, something is better than nothing. Even though default key is not flexible, still it is capable enough to give you the security of your data. So if you don't have the skills or the knowledge or the understanding that how you create a custom key, it's better you start using the default one. And eventually, once you move on and start understanding the different concepts, you start managing your own keys. So if I just go to this default key, you will see that there's no option to change it, to modify it, to share it. Nothing is there. It is plain and simple. That's been used to perform the encryption. Now, if I just go to the customer managed keys right now, I have none. So I deleted the previous keys because it cost you few cents per month, few dollars per month. I think one key will cost me $1 and few cents. So I just create a new key right now, the custom CMK, and show you that how it can be customized. What I will do is that I click on create key, and the very first thing is it will just ask me create alias and description. So what I'll just do is that I'll just type the display name. Let's type in, for example, custom underscore CMK, and then, or I just type in, for example, custom CMK. Let me just go with this one. And in the description, this key will be used to encrypt my financial data, something like that. I can just go to advanced options. I can also share this key with some external users if I want. But anyhow, I will not do that at this point of time. Click on next. I can add a tag value, but this is optional. Click next. Now, for this key, I can define the key administrators. Now, if you remember, I created these IAM users, right? So I can choose the key administrators. For example, in my case, I choose, let's suppose I choose Steve and Suresh. These will be the key administrators. So the key administrators can change the properties of this key. And also I can allow these administrators to delete this key. Steve and Suresh, being my IAM users, can delete this key. They can change the properties of this key. So I picked 2 IAM users out of all these. Now I hit next. Now I define the key usage permissions. Now I will be choosing that who are the people in my organization who can use this key to encrypt and decrypt data. You can see on the top, select the users and roles that can use the customer master key to encrypt and decrypt with the KMS API. So I'll use all these IAM users who will be using this key to encrypt and decrypt data. Okay, so they can use this key. I can just add another account, so I can just define the other account ID so that I can share this key with some other account. But I'll do it afterwards, not right now. Hit next. This is a JSON policy for this key. Hit finish. And as you can see, my key is being created. You can see your customer key was created. This is the key ID. And this is the creation date and time. Fine. So this service is not free of cost. Whether you use the default keys or the custom keys or you create them, you have to pay for that. Okay. So the thing is that this has been done. Now I'll show you the process that how you perform the encryption, and the decryption part will come afterwards. Okay. So let's do one thing. Let's go back to the volumes dashboard, and let's create a new volume. So let's go to click on create volume, and this time I choose only 1 GB or 1 gigabyte in the AP South 1P. I would choose this option, encrypt this volume. I would choose the default key. Can you see that? Default AWS/EBS. Now, how it makes a difference, I'll show you afterwards, not right now. So I choose my default key. So this volume of 1 gigabyte that I'm creating, or in the process of creating, will be encrypted using the default key. Fine. So I click on add tag. Let's name it as this is my encrypted volume. That's being encrypted using the default CMK. Fine. I click on create volume. Done. So one volume has been created using the default key. I create another volume. Just click on create volume once again. And this time I just create the same size, 1 GB, same easy. Choose this option, encrypt this volume. But this time the master key would be the custom CMK, the customer master key. Okay. It automatically shows you the description, the account ID, who owns this key, the key ID, and the key Amazon resource name. I hit add tag. I'm just gonna assign a name to it. So I'm gonna just assign a value that is, for example, encrypted volume that's being encrypted using the custom CMK. Fine. Click on create volume. Fine. So as if now I've just shown you that how you perform the encryption. Once I discuss with the snapshot, I'll discuss with you that how it makes a big difference. If you manage the volumes that are being encrypted using the default CMK, and you manage the volumes that you encrypt using the custom CMK, I'll discuss that afterwards. Fine. So these are the important things that you have to understand before we can start understanding the different types of volumes. Now, the next thing that we understand is the next concept that we understand is that we are through the encryption now. The next concept that we will understand is the types of volumes. See, the volume types are important for you to understand from the operations point of view and also from the exam point of view, because in the exam they will ask you they will put some questions in the form of some scenarios where you have to just pick that which of the volumes is best suited for that particular scenario. See, first thing you have to understand, in a free tier account, you get only 2 volume types. Okay, first of all, what are the different volume types? The different volume types are the following. So let's list them. First one is the general purpose SSD. Okay, let me just write it down once again. Sorry for the bad handwriting. So let me just. The first one is the general purpose SSD. In the short form, it's labeled as GP2. That is short form of it. It's called the API name or small name or short name GP2. The second one is provisioned IOPS. Provisioned IOPS SSD. In the short form, it's called as IO1. The third one is magnetic. Okay, magnetic. We don't have any small name for it or short name for it. The fourth one is throughput optimized HDD. The short form is ST1. So let's write down once again. This is the ST1. Okay. And the fifth one is cold HDD. The short form is SC1. Fine. Now, in a free tier, the volumes that you get are the following. This one and this one. The general purpose SSD and the magnetic. These are the only 2 you get in a free tier account. In a free tier account, these are the 2 ones that you get. Right? So, I start labeling the differences right now. But before that, let's understand from that how you categorize the volumes in 2 different categories. So 2 broad categories. So the 2 broad categories of the volumes are, first one is SSD. SSD stands for solid state disk. Now, and okay, I'll come to that afterwards. And the second one is the HDD. That stands for hard disk drive. SSD is much faster as compared to the normal hard disk, but this is a costlier option. So nowadays we have the SSD disk that part of the premium laptops like MacBooks, iMacs, even the HP Pavilion series laptops you get on some high-end servers. The SSD disk is much faster. It is costlier as compared to the hard disk. Okay, so this is you can say this is a traditional hard drive. This is the traditional hard drive that you use. It is slower, and also it is a cheaper option. It's a cheaper option. So these are the 2 broad categories of 2 different volumes that you get: solid state disk and hard disk drive. Solid state disk are much faster, much more costlier. This gives you a very high performance. Okay, this gives you high performance. Now, to analyze the performance of the solid state disk, the unit you use is IOPS. This stands for input output. Operations per second. Higher the IOPS, the higher is the performance of the SSD volume. For the HDD back, the unit used to analyze is called the throughput. Usually it is in maybe byte per second. Higher the throughput, better is the performance of the HDD backed volumes. Okay, so if you just search, or if you just broadly categorize the volume types, we have the SSD volumes and the HDD volumes. So going on the top, the SSD are the first two and the HDD are the last two. Magnetic is other type of storage. It is one of the slowest storage options. So SSD backed are the first two and the HDD backed are the last two. So now the thing is that I'm gonna just give you a brief overview of each of the volume types so that you understand that in which of the situations and scenarios you have to use that volume type. Okay, so I start with the very first one. That's the general purpose SSD, which is most commonly used. What is that? That is the general purpose SSD, or it's called the GP2. That's the most commonly used solid state disk. Now the thing is that this is the one that's used for small to medium sized environments. Okay, and it will not give you any consistent performance. So no consistent performance. It can give you high performance, sometimes medium, sometimes low, depending upon how much CPU credits it has. I'll come to that. Or IO credits, I would say that. So no consistent performance. So the graph will go up and down depending upon how much IO credits it has. We'll come to that. On an average, it gives you the performance of 3000 IOPS. On an average, you get 3000 IOPS. The maximum / the burst performance, the maximum roof performance, or I would say the burst performance it can hit is 10,000 IOPS. Okay, so what are the use cases? For example, the use cases are for development environment. It's used for the development environment. It's used as system boot volume. As system boot volumes for development environment. So this gives you this doesn't gives you any consistent performance. It's used for small to medium size environments. You don't get any consistent performance out of it. You don't expect any very high or very consistent performance. Fine. So on an average, you get 3000 IOPS. Maximum, you get up to 10,000 IOPS. And it used in the cases, for example, the development environment, it can be used as the system boot volume. So this is about the general purpose SSD or the GP2. Okay, so that's about the thing. The second thing, the second type of volume that we will discuss would be the provisioned IOPS. What is that? That's the provisioned IOPS SSD, or in the short form it's called IO1. This is the SSD backed volume. Now this gives you the highest and consistent performance throughout. Okay, it gives you the highest and consistent performance. The maximum that you get, I would say the burst performance, that it will achieve from it is 64,000 IOPS, which is more than 6 times that you get with the general purpose SSD. More than 6 times. Okay, so it gives you the highest and consistent performance, and this is the costliest out of all the EBS volume types. Is a Ferrari of the volumes, you can say that. And what's the use case? The use cases are that it's used for, like for example, Cassandra, very high performance intensive databases, Cassandra, MongoDB, DynamoDB. So in any of the environments where your databases need very high and consistent performance, you go with this thing. Okay, SAP HANA. So in any of the environments, for any of the applications, if you want to have very high performance, consistent performance, then you would just go with this thing. Let's just write on again. So what is the use case? So if you're expecting, so you want for the applications, if you need very high performance, if you need ultra high performance, okay, in terms of IO operations. Okay, for example, you want to do that for Cassandra databases, or I would say MongoDB, SAP HANA, any type of application database that needs very consistent and high performance, you go with this one. Okay, so you have to shed out a lot of money, if you have to go for that. This gives you the highest performance, consistent performance. For example, it can be used for the e-commerce platforms. Okay, so this is about the provision IOPS. Now the thing is that whenever you provision this volume, you have to follow 50:1 ratio. 50:1 ratio when you provision this volume. This means that for every 1 gigabyte of the volume, you can provision up to 50 times its IOPS, not more than that. And I think it's up to a certain limit. So for example, if I just go back to this volume dashboard, click on create volume, fine. So I choose, for example, provision IOPS. Right now, the size is, for example, I just make it as 10 gigabyte. Okay. So the maximum I can achieve is 500 IOPS maximum. So I just make it as to 500. Okay. As soon as I make it as 501, you can see the message. The maximum ratio of 50:1 is permitted between IOPS and volume size. And I think it's up to a certain limit. After the size of the volume, it doesn't make any difference. But for the volumes less than 1000 GB or 2000 GB size of the volume, you have to follow the 50:1 ratio. For each 1 GB of volume, you get only 50 times its IOPS, not more than that. Okay, so this thing you have to keep in mind. Right? Let's understand that the third volume type. The third volume type that we have is the throughput optimized HDD. It's called ST1 in the short form. Now it's used for the long sequential operations. For example, it's used for big data. Okay, it's where you have we have the or ETL. So where you just take care of the long sequential operations, you go with the throughput optimized. And the thing is that you get the throughput in terms of, so to get the performance, to gauge the performance, the scale or the unit you use is the throughput. What is that? That's the throughput. Throughput you get is maximum 500 megabyte per second. Okay, this is the throughput you get per second per gigabyte. Fine. So this is mainly used for the long sequential operations like big data, ETL, log processing, and so on. Fine. The fourth one that we'll discuss is the cold HDD. It's called the SC1. This is used to store your cold data or archive data which you don't access frequently. The throughput you get is half of what you get from the throughput optimized HDD, that is 250 megabyte per second per gigabyte. And it's a cheaper option as compared to the throughput optimized HDD. So you store the data that you don't access frequently. You don't expect very high performance out of it. Okay. The last option that we're going to discuss is, so that's the fifth option, is called magnetic. Now the magnetic is a previous generation volume. Okay, so by the way, we also use the other term for the magnetic, is called standard. It's a previous generation volume. I'm sorry. It's a previous generation volume. Right? This is cheapest option. This gives you the worst performance. This will give you the lowest performance out of all the volume types. You get on an average the IOPS. On an average, you get only 100 IOPS. So you get only 100 IOPS as a performance. So the question really is, why are you going to use it? So what's the use case? Use it for the experimentation, for some lab purpose. Okay, you're using for the experimentation for some lab purpose, and store your archived data because it's one of the cheapest options. Use it for the experimentation, store your archived data. It gives you the lowest performance, cheapest of all. It's a previous generation volume. Okay, so that's it. These are the different volume types that you have to understand the different use cases, because in the exam you may get some questions where they just give you different scenarios, and based upon those scenarios you have to choose the best available volume. Now basically you have to understand two important points you have to understand. For example, you may see a question in the exam. The customer wants to try out the performance of the EBS without incurring any charges. Which of the volume types will help him to achieve that? So the answer would be magnetic and general purpose SSD. These are the two volumes you get in a free tier account. So the customer can try the and understand the functions of the EBS without incurring any charges. So he or she can use any of these two different volume types, general purpose SSD and magnetic, to try out the function of the volume, understand how it performs without incurring any charges. You may see a question that a user is using the general purpose SSD volume, but now the performance is being depleted and the user is looking for a very high performance because the database that is running needs very high performance because of a lot of I/O operations coming in. The performance of the application is being impacted. So how the user can increase the performance of the volume or the application in case if the volume is sluggish? The answer is that the user can change the volume type from general purpose SSD to provision IOPS. So if the general purpose SSD is sluggish and user is not able to achieve what he wants to achieve, the application is running slower. So in that case, the user can change the volume type from general purpose SSD to the provision IOPS to get the higher performance. Okay, so these are the different volume types. So these are the different volume types that we have discussed right now. Fine. That being said, this completes the conversation on the volumes. The next thing that we'll discuss right now is the snapshots. Now, snapshots is a very, very interesting topic because I know that the EBS is quite monotonous. It includes a lot of theory, but snapshot is quite interesting because it includes a lot of concepts that will help you to understand that how exactly the backups are being created and maintained in AWS. Okay, so the next thing that we'll discuss right now we'll discuss the snapshots or snapshot. So what are snapshots? Snapshots are the incremental backups, or I would say, they are point in time backups. They are point in time backups. They're point in time backups and they are incremental in nature. I'll discuss what do you mean by incremental in nature. What do you mean by incremental? What's the point in time backups? We'll come to that. Basically, what happens is, first of all, let's understand the basics. You want to back up the volume. Okay, you want to back up the volume. The only strategy that works over here is, if you want to back up the volume, is that you just back it up using the concept of snapshots. You back it up using the concept of the snapshots. Now, the thing is that snapshots are just not the backups. They're used for two more reasons. One is disaster recovery. I'll elaborate these two different points of all the 4 points one by one as we just progress further and understand the concepts. And also it is used for data migration. So don't just think that the snapshot is just for the backups. It's used for the disaster recovery and for the data migration. Okay, now how this works for you, let's understand the concepts right now. See, the thing is that, let's imagine this is my volume. Okay, you take a snapshot out of it. It's a snapshot, it's a backup. That snapshot data is being saved into one of the S3 buckets that's being maintained by AWS. It's AWS managed bucket. You can't see exactly where that bucket is, but that's the backend mechanism. The snapshot data is being captured and saved into one of the S3 buckets that's being managed by AWS. It's a pure backend process that you can't see. They multiply the copies of that data to make it more redundant for you. Second thing, a volume is an AZ specific resource, but the snapshot is region specific. Okay, so we have to understand the differences between these two. So the snapshot data is being captured and saved into one of the S3 buckets being maintained by AWS behind the scenes. Okay, now the thing is that I discussed these two different things: point in time backups and incremental backups, or incremental in nature. Especially I'll just focus upon the incremental. So why snapshots are called incremental? What's the purpose? See, it's called incremental. The reason being, whenever you just capture a backup the same volume again and again, the next snapshot that you take will only capture the added or changed data with respect to the previous snapshot. Okay, let's do one thing. Let's take one example, because this is a very important concept. If you understand that concept, then half of the snapshot is understood. But before that, there's one more concept we have to understand. So for example, this is the volume. You can take the snapshot out of this volume, and you can create a duplicate volume, from that snapshot in same or different AZs/regions. This is AZ or different region. So I can just carve out a duplicate volume from a snapshot in the same AZ or a different region. Fine. So from the snapshot, you can restore a duplicate volume. Okay. Then other thing is that if the snapshot is encrypted, I'm sorry. Let me just come back again. If a volume is encrypted, so it is labeled as E, it's encrypted, the snapshot will also be encrypted. And the duplicate volume will also be encrypted using the same key. First of all, you have to understand that basically you encrypt the volumes. You can also encrypt the snapshots. But what happens is that if a volume is encrypted, the snapshot is automatically encrypted using the same key. And if you carve out a duplicate volume from that snapshot, it also becomes encrypted. Okay. Let's come to the next part. The next part that we have to discuss is that how these snapshots are being considered as the incremental backup strategy. So we're going to just take one example right now. Let's imagine this is a volume of 30 gigabyte. Okay. Now you can also automate it, or you can just do it manual. It's up to you. So let's imagine after a gap of 1 day each, after a gap of 1 day, you want the snapshot to back up the volume again, because on this volume, you may add on or change some data. Fine. So let's imagine one thing. Let's consider this thing, that you have the responsibility to just create a snapshot or back up this volume after a gap of 1 day. So on Monday, that's the first day of your working day, you say, okay, let's do one thing. Let's capture the first snapshot. So just label it as my snap 1. So on the very first day of my week of working day, I took the first snapshot. That's a snapshot 1. Fine. Now the snapshot 1 by default will just take the entire space into that AWS managed S3 bucket. So in that S3 bucket, it will just take the entire space and save that 30. It will just take the entire 30 gig of space in that S3 bucket. So any first snapshot you take from the volume will just take the entire space from the bucket, and it will just capture the data, anything that's being stored on that volume. It will back it up, but it will just take the entire space of that, depending upon what's the size of the volume. It will take the entire space, and also it will just back up the data that's being stored on that volume. Fine. Now you gave, let's suppose that you want to give a gap of 1 day. So on Wednesday, so you leave Tuesday over here. On Wednesday, you decided to capture the second snapshot. Okay. Now, the snapshot 2 will not capture the same 30. It will not take the same 30 GB of space in the S3 bucket. It will not do that. It will say that after the first snapshot 1 was taken, what are the blocks of data changed on that original volume? Which are the blocks of data that were changed on that original volume after the first snapshot 1 was taken? Let's imagine after the first snapshot 1 was taken, the first snapshot was taken, we added on 2 GB of data. So it would, or I would say 5 GB. Let's say 5 GB. So 5 gig of data was added on or put into that volume. So it will increment only that 5 GB of data that was added on to that original volume after the first snapshot 1 was taken. So the snapshot 2 will just capture that added data and put that to the bucket. Fine. Let's take one more example. So on Friday, you took the third snapshot. Now the third snapshot will see that after the previous snapshot 2 was taken, the previous snapshot second was taken, were there any blocks of the volumes? Were there any blocks of data changed on the original volume? Was there any change? Was there any change on the original volume? Any add-ons? Any changes? So for example, after snapshot 2, I changed 2 gig of data. So snapshot 3 will just add on only 2 gig of changed data and put that into this bucket. So 20 plus 5 plus 2, we have 37 gig. So that's why we say that snapshot is an incremental backup strategy in such a way that whenever you take the consecutive snapshots after taking the first snapshot, those consecutive snapshots or the future snapshots or the extra snapshots will just add on the data that was changed or added on to the original volume. That's why it's called the incremental backup strategy. Now you may ask this question, how does it benefit us? You get a benefit in such a way that, let's suppose that it's not the incremental backup. Then you have to pay for 90 gig of storage. See, the thing is that you have to pay for each gigabyte or each GB of snapshot storage. Nothing is free here. You have to pay for each GB of snapshot storage. So instead of paying for 30 plus 30 plus 30 equal to 90, you have to pay for 37. So it brings down the cost of the snapshot storage for you. So instead of paying for 90 gig, you have to pay for 30 gig, 37 gig. Instead of paying for 90 GB, 90 GB, you pay for 37 GB. It's a huge difference. Now, let's turn on this table and understand the next part of it. We discussed the strategy that you can just carve out the duplicate volume from that snapshot. Let's imagine from this snapshot 3, I just carve out a volume. So from this snapshot 3, I carve out this volume. This volume, if I just capture the volume from the third snapshot, it will encapsulate the data from snapshot 3 plus snapshot 2 plus snapshot 1, which is equal to, so this volume would be of 37 gig or 37 GB. So whenever you take the snapshot, it will capture the data of that snapshot and all the previous snapshots. Similarly, if I take the volume from this snapshot, it will capture the data of that snapshot and the previous snapshot, which is 30 plus 5, 35. Okay, so it will be, this size of the volume will be 35 gigabyte or 35 GB. Similarly, if I take the volume from this snapshot, it will only capture the data of that snapshot. Only, that's it. That's of 30 gig. Okay, so this is the essence of the snapshots. This is the essence of the snapshot. If you understood this concept, then snapshot is a very easy thing for you to understand, because once I start showing you the configuration and the usage of the snapshot, it's quite easy. So let's do one thing. Let's go back to the main page and let's pick this encrypted volume. Okay, let's do one thing. Let's create a volume. I create a volume of 1 gig in AP South 1B, and I just name it as unencrypted volume, just to label it as if now unencrypted volume. Fine. Then I click create volume. So I just created this volume right now. I just created it. I click close. Now let's do one thing. I just go ahead and just remove this filter, and this is my unencrypted volume. This is my unencrypted volume. I choose it, go to actions, and can you see the option at the top which says create snapshot? Let's go there. I can assign a description that is unencrypted snapshot. So Why this is unencrypted? Because the volume itself is not encrypted. Okay, and I can just add the same tag to it. Fine. So I click on this snapshot ID, and this takes me to the snapshot dashboard on the left hand side, and this creates my unencrypted snapshot of that unencrypted volume. Now I can take this snapshot, go to actions, click create volume, and I can just create a volume of a different type, of a different size, and even in a different zone. Can you see that? I can just create a duplicate volume from that snapshot of a different type, different size, and a different AZ. So I can name it as my duplicate unencrypted volume. Fine. Click create volume. Done. So you can use a snapshot to carve out, to just create the duplicate volumes. You can just go about doing that. Fine. Now, if I go to snapshots, you can also use a snapshot to just migrate your data to a different region. For example, this snapshot is in Mumbai. So first thing first, the snapshot is a region specific resource. So any snapshot that you create is a part of that particular region. So what I will do is I choose this snapshot and I just go to the actions and I just click on copy. I can copy over this snapshot from Mumbai, for example, to Singapore. Okay, click copy. Now this copies over the snapshot. You can see it says snapshot copy operation has been initiated. I just go to the Singapore dashboard and you can see that it's been copied over. I've just copied over the snapshot from Mumbai to Singapore. That's how you go about doing that. So this is an effective strategy, an effective tool for you to just migrate your data across different regions. And this is used in case of creating backups of the backups, for data migration, and also for the disaster recovery. So for example, my main infrastructure is running in Mumbai, and for some reason it goes down. That's fine. I can recover the data from Singapore because I have the duplicate backups or the backups of the backups maintained in Singapore. So snapshot is a very, very effective strategy for data migration and disaster recovery. Fine. Now let's do one thing. Let's go to the volumes. So the thing is that I just go to the snapshot. You can also share the snapshot with the other account or the external AWS account. So I choose my snapshot, which is being unencrypted. Okay, let's go to Mumbai right now. Let's go back to the main region. I choose my unencrypted snapshot, go to actions and click on modify permissions. Now any snapshot which is unencrypted or not encrypted can be made as public. See, first of all, as per the best practice, you should never ever make any snapshot public in nature. If you do that, then if you change the category public snapshots, your snapshot will show up over here. If you change the category from owned by me to the public snapshots, you can see all the public snapshots that are being shared by some other accounts. So if I just go back to owned by me, choose this snapshot which is not encrypted, I go to actions, click on modify permissions. I can make it public, or I can share it privately with some other account. Let me do one thing. Let me just open my other account real quick. Just give me a few seconds over here. So just give me a few seconds. So I'm just trying to open some other account, my secondary account over here. Let's do that. And I just show you that how you share the snapshots across two different accounts. So let me just log in real quick to a different one. Okay, so I'll fetch my account ID from here. So let's go at the top right hand corner, go to my account. Let's copy my account ID from here. Shoot back to my primary account. So let me just drag and drop this thing and paste it and add permission. Okay, so this account number is being added. Hit save. So I've shared my unencrypted snapshot with some other account. If I just drag and drop my other account screen right now, I go to services, I go to EC2. I just go to the snapshots. I change the category from owned by me to private snapshots. And here we go. It's been showing up. So that's how you share these snapshots that are unencrypted with some other account. Fine. That's the story behind the unencrypted snapshots. Now, let's come to the encrypted. I have the volume. First of all, let's pick the volume that's being encrypted using the default CMK. Fine. I just do one thing. I just create a snapshot of it. Now, once I create a snapshot, the snapshot will be encrypted using the default master key. So I choose it, go to actions, and click on create snapshot. Let's name it as, so this is my encrypted, this would be my encrypted snapshot. Let's name it once again, encrypted snapshot. That would be, that's been encrypted using the default CMK. Let's just copy this tag, name it. Fine. I click on create snapshot. So I created a snapshot from the default customer master key. I did that. Fine. Now, let me show you one thing. I choose the snapshot, go to actions, and can you see this thing? The modify permissions is being grayed out. The option that's the modify permissions is grayed out. On the other hand, if I just show you the unencrypted snapshot, the option is there. If I click on modify permissions, I can make it public and private. Okay, but if I go with the snapshot that's being encrypted using the default customer master key, you will see the modify permissions is being grayed out. It's disabled. The crux of the story is the snapshot which is being encrypted using the default customer master key. You can't share it with any other account and you can't make it public. First of all, anything that's encrypted cannot be made as public. But even in this case, because this is being encrypted using the default CMK, the default customer master key, in that case, the snapshot cannot be shared with any other account owner because the option is grayed out. It's disabled for you. So this is the flexibility I was talking about. Okay, so anything that's been encrypted using the default keys can be managed in the same account only. Okay, now let's go with the the volume that's being encrypted using the custom CMK. I choose it. Okay, I choose this, go to actions, click on create snapshot. So now this would be my encrypted snapshot, which will be encrypted using the custom CMK, because this is being created from the volume that's being encrypted using the custom customer master key. I add a tag to it so that we can just recognize it. Just add the value. I just click on create snapshot. Done. I click on the snapshot ID. So this is my snapshot encrypted using the same custom CMK. Okay. I go to actions and I can see the modify permissions being showing up. I click on that. Now, of course, if anything is encrypted, you can't make it public. But at least in this case, I can make it private. I can share it privately with any other account owner. So I specify the account number. Let me just do that once again. So I just specify the account number. Let me just get the account number real quick. So I mentioned the account number of the external account, my secondary AWS account, add permission, click save. Okay. Now this is where the main thing comes up. If I go to my snapshot dashboard, hit refresh, it shows up. But the thing is, I can't straight away use that snapshot. I have to create a copy of that snapshot using my own key. This is my secondary account with which this snapshot was shared. This is my main account. This is my main account. Okay. So I chose my snapshot, click modify permissions, and mention this account number of the account. So this is my secondary account. I've just shared my snapshot with this one. Any snapshot that which is encrypted and you share it with the external account, that external account has to create a copy of it first using its own key. So I choose it, go to actions and click on copy using the own key. Okay, click copy. It's initiated. Click close. Now you will see that eventually it will fail. I'll let you know why. It is pending right now. If I just try to create a volume out of it, it will not work for you. Because whenever you share any snapshot which is encrypted with any other account, that external account or the other account owner has to create a copy of that snapshot first using its own key. And then that snapshot can be used to carve out a volume. You will see that it is still not doing anything. The reason is I haven't shared the key first. So if I share the snapshot which is encrypted using the custom CMK or the custom master key, the main thing I have to do is that I have to share the key. So how I share the key? Let me just go back to my primary account. I just go to the KMS console, click on this key, the custom CMK, scroll down and click on this option, add other AWS accounts. Add another account, mention the account ID, click save changes. Okay, now this key has been shared. I just drag and drop my screen of the other account, hit refresh. I don't think it will work now. So let me do one thing. Let me share the snapshot once again. So I go back to my main snapshot dashboard on my primary account. I share the snapshot once again. Fine, done. I shoot back to the secondary account, hit refresh. Let me do one thing. I think it will take some time. Let me just get rid of it if I can. Okay. Let me share it. Okay. Let me just create a copy of it now. I go to actions, click copy. Let's do it once again. Okay. Let's see if it works. or else I have to, okay, it worked now. Can you see that? It immediately worked because before I initiated the process to just share the snapshot with this account, first thing first, I shared the key. Now I can just choose this copied snapshot, which is being encrypted using my own key on this secondary account. I can go to actions and I can just carve out a volume out of it. Okay, can you see this? I can use my own master key in this account to carve out this volume. Click create volume, and I can attach this volume to any instance in this secondary account. So that makes a big difference. Whether the volume is encrypted, it's not encrypted, and if it's encrypted, whether you have encrypted it using a custom CMK or the default CMK. That being said, this completes our conversation on the EBS snapshots and volumes. Thank you so much for your time and patience.